To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today also I am going to discuss with you all the last question, that is question number 9 of part B of paper 2 of the G.C.E O-level 2020 examination. So here this is the last question, question number 9, A part. So as you can see, this is the electrochemical cells. So then you all know it is a chemistry related question. So this part A is chemistry related. Then A part. The cell U shown below is an electrochemical cell, while the cell W is an electrolytic cell. So they have mentioned that. They have said cell U is an electrochemical cell, cell W is an electrolytic cell. What is the difference? Now, in both, there is electrochemical processes taking place, that is oxidation and reduction. But in an electrochemical cell, the cell U, what will happen? Due to a chemical reaction. When the chemical reaction takes place, there is electricity generated. So, here the chemical energy is converted to electric energy. If you look at the cell U, you can see a copper electrode and this side zinc electrode. So, two different metals. Then there is dilute sulfuric acid solution. So, there will be oxidation and reduction taking place. Because of that, there will be a flow of charges and that will lead to the flow of current, electricity. So, from chemical energy, electric energy will be generated. If you look at cell W, you can see here aqueous copper sulfate solution. So, you all know it is a blue color solution. Now, here it will be a blue color solution. And here both the electrodes are same, carbon electrodes. And also you can see there is the batteries, power supply is there. So, this is an electrolytic cell. So, there we supply electricity and make a chemical reaction to occur. Normally, a non-spontaneous reaction will occur when you supply electricity there. So, that is how the cell W works. So, because you have the terminals, positive and negative terminals, you all know this particular electrode will become positive, this will become the negative terminal, and the anions or the negative ions will get attracted to the positive terminal. So, because of that, there will be oxidation and that will become the anode. At the same time, the positive ions or the cations will migrate towards this carbon electrode and there will be a reduction happening. When the positive ion goes towards the negative electrode, there will be reduction and therefore that will act as the cathode. So, you are familiar with all these reactions. This will be the anode and this will be the cathode. But here in the cell U, what happens? There is the copper electrode, zinc electrode. Now, you can remember students the activity series. Can you all recall the order? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. Then you have copper, mercury, silver, platinum and gold. So, there if you look at the reactivity of zinc and copper, you all know zinc is higher in the activity series, so it is more reactive. So, therefore, what will happen here? The zinc solid will become zinc 2 plus aqueous, losing 2 electrons. So, because of that, here of course, the oxidation will happen at zinc. Oxidation happens at zinc. Therefore, the zinc electrode becomes the anode. At the same time, now copper is not that reactive, but there is dilute sulfuric acid. So, there is H plus, SO42 minus as well as H plus and OH minus from water. Now, here the H plus ions will go towards the copper electrode and there they will take up electrons and will get reduced to H2 gas. So that will happen near the copper electrode because copper is less reactive. So that is the cathode because it is the reduction. Here copper will be the cathode. So here of course I have written down all the information. From by looking at the two cells, you can get all this information. So cell U, you know it is an electrochemical cell. So there should be a chemical reaction that generates electricity. Now here, since at the zinc electrode, zinc is oxidized and the zinc 2 plus goes into the solution, there will be electrons remaining on the zinc plate. So because of that, this becomes the negative electrode, and there here you can see near the copper electrode, H plus ions are taking up electrons. So because of that, copper becomes the positive electrode. So here anode is zinc, which is negative, and cathode is positive and it is the copper electrode. At the same time, here you can see we supply electricity, and because the positive terminal is connected to this electrode, that becomes the positive electrode. Negative ions go towards that and gets oxidized there. Because of that, the positive electrode becomes the anode. At the same time, because this carbon is connected to the negative terminal, that becomes the negative electrode, where the cations go towards the negative electrode and they get reduced. Because of that, it becomes the cathode. At the same time, you all know this is an aqueous copper sulfate solution, which is blue in color. So there, what do you all know? There is both copper 2 plus ions and sulfate ions, Cu2 plus, sulfate ions. At the same time, there is H plus and OH minus ions. So out of these, you all know when there is Cu2 plus and H plus, Cu2 plus has the lower reactivity. Because of that, that will get reduced. At the same time, when you have sulfates and OH minus will get oxidized. So because of that, there will be oxygen gas formed here. You all know the reaction. O2 gas will be liberated there. So if you look at both the cells, you will see observations. Now here you will see the zinc plate dissolving. At the same time, near the copper electrode, you will see the liberation of gas bubbles. Then here, near the anode, you will see the liberation of oxygen gas, and at the cathode, you will see the deposit of copper. So you will get the reddish brown color deposit there. And also, you will see because the copper deposits there, from copper sulfate solution, copper will be used up. Because of that, you will see the decrease in blue color of the solution. So that is the theory related to these two particular cells, the electrochemical cell and the electrolytic cell. I am sure you can recall all those. We have seen these cells also in the lab. So then, if you are to answer the questions related to that, the first question you can see, in which cell above is chemical energy converted to electrical energy? It is cell U, electrochemical cell, cell U. Then the next question, again I have put the questions and the introduction. The second question, what is the name by which the anode reactions occurring in the two cells are known in common? So you all know by convention, anode means where oxidation occurs. Oxidation is losing of electrons. When a species loses electrons, then we call it oxidation. So what is the name? That is oxidation. Oxidation. Is that clear? Then the next question. Again, the introduction and the diagrams are given. Third question. Indicate the half reaction occurring at the anode of cell U by a chemical equation. So here I told you all zinc is the anode because there is oxidation. What is the reaction? You can remember zinc solid is there. That becomes zinc 2 plus aqueous by losing 2 electrons. Now here students, this is the complete oxidation reaction. You all can remember normally we write the physical state. But for this particular question, even if you don't write the physical state, it is fine. As long as you write it like this. This is important. Now you have to write zinc becoming zinc 2 plus 2 electrons. It has to be balanced. So this physical state is optional. So this or this is fine. It is an accepted answer. Another way you can write, normally you all know for a chemical equation, we don't put minus. Either on the reactant side or product side, we don't put minus. So that is why although zinc loses electrons, we have the zinc as the reactant and zinc 2 plus and electrons as the product. So what you can do is you can write, now here I will write this as a note. You can write like this, minus 2 electrons giving rise to Zn2 plus, but you will not get the full marks. Only half the mark will be given. Half the mark will be given for this. Let's say for the question, if the total marks is 2, you will only get 1 mark here. But for this, one of these two, you will get the full mark. So here, you will get the full mark. Here you will only get half the mark because you have written it in the minus form. So normally the correct way is to write it like that. Is that clear, student? So then the next question. So again, I have given the introduction and the diagram. Fourth part, state the convention used to identify the anode and cathode in cell W. Now anode and cathode I explained to you all, because this positive terminal is connected to this one, this becomes positive and ions get attracted to that. Their oxidation happens. Because of that, that becomes the anode. This becomes the anode. Then on this side, we have the negative terminal. So this electrode becomes negative. Cations go towards the negative terminal. M plus ions, let's say. I'll put N minus here just to identify, just for you all to understand. So when the cations go towards that, there is reduction taking place. So because of that, this becomes the cathode. So what is the convention? The carbon electrode connected to the positive terminal becomes the anode, and the carbon electrode connected to the negative terminal of the power supply becomes the cathode. That is the convention. That is what you need to write here. The electrode connected to the positive terminal of the power supply becomes the anode, and the electrode connected to the negative terminal of the battery or you can say power source becomes the cathode. You can say becomes the cathode or is the cathode. Either way is fine. So you have to mention this. Based on how they are connected to the external power supply or the battery, the anode and cathode are defined. So is that clear, student? So with that, I'll move on to the next question. Again, we have the cells given to you here. The fifth one, A part. What change in color occurs in the electrolytic solution when cell W operates? So, electrolytic solution is here aqueous copper sulfate. I told you all it is the blue color. What happens when copper deposits at the cathode? Copper ions are removed from the solution. So, because of that, the color will decrease. So, here you can see what change in color occurs in the electrolytic solution when cell W operates. You can say blue color decreases. Color decreases. Blue color decreases, and you need to explain the reason for this. So, here you can say blue color decreases, or you can say blue color becomes colorless. So, here another way you can write blue color becomes colorless. That is also correct. So, one of the two answers is accepted. Then to explain the reason, what can you write there? What I explained to you all, you can say the Cu2 plus ions from copper sulfate aqueous undergo reduction. The Cu2 plus ions give the blue color to the solution. Because Cu2 plus is reduced, the blue color decreases. Is that clear? So, you have to say the blue color is given by copper ions, and the copper ions are reduced. Because of that, the blue color decreases. You can say reduced, or they are removed from the solution. Because of that, the blue color decreases. Is that clear, student? So, with that, I'll move on to the next question. Here again, I have the same diagrams given to you. The sixth part of the question, which electrode is dissolved when the above cells operate? Now, here I discussed all the reactions with you all. You all can remember. Now, in this one, near the zinc electrode, there is oxidation. Zinc becomes zinc 2 plus. Whereas copper electrode, there is the liberation of hydrogen gas bubbles. On this side, near the carbon electrode, again there is liberation of O2 gas. So, you can remember here there is H2 gas. Here there is O2 gas. I explained this to you all. Here there is the deposit of copper. And here there is the dissolving of zinc. Zinc becomes zinc 2 plus. So, which electrode is dissolved when the above cells operate? It is only the zinc electrode. So, here we have to say zinc electrode. Is that clear, student? Zinc electrode. So, that is the answer. Then the next question. Okay. So, this is the B part. Now, we completed the A part of the question. This is the B part of the question. There is a diagram given to you. When you look at the diagram, you can understand this is a physics related question. Part B. In order to operate a certain household electronic equipment, the domestic electricity supply has to be converted to a low voltage direct current electrical supply. So, it has to be low voltage and also direct current electrical supply. For that, an arrangement consisting of the following parts is used. So, you can remember, students, we have discussed the household electric circuits. Now, from the national grid, power is supplied to the distribution sub-centers. From that, it gets supplied to the household. To the household, you can remember it is 230 volt, 50 hertz alternating current. But the devices that we use in the household, some of them need high voltage, some of them use very low voltages. So that is what is mentioned here. One thing, it has to be low voltage and it should be direct current. So here if you look at the diagram, students, you all can see here, of course, it is 240 volts. Normally we have discussed 230 volts. Here they have specified it as 240 volts alternating current. And there you can see there is a transformer used where you get the 12 volt alternating voltage. So immediately you can see the voltage decreases. That means it has to be a step down transformer. Now transformer converts the voltage of the input current to the output current. So input or primary voltage becomes the secondary or output voltage. So here, since the voltage decreases, it is a step down transformer. But you all know, when the voltage decreases, because the energy doesn't change, we assume that there is no energy loss. That is, the transformer is 100% efficient. The output current is higher than the input current. In a step-down transformer, you have to remember, students, when the voltage decreases, the current increases. That is because the efficiency of the transformer is 100%. Then you can see a full wave rectifier because we have alternating current here and this becomes the direct current there. So after you get the direct current, there is component X, and after the component X, you can see smoothened direct current. So what is the process happening there? In X is the smoothing process. Now when we say smoothing process, what do we need to use? In addition to the full wave rectifier bridge circuit, that is done using diodes. 4 diodes connected in a bridge circuit, and with that, if you use a capacitor, we get the smoothing of rectified current. Is that clear? Then we have the electronic equipment there. So that is the process happening here. Now let's look at the questions. First one, A part. What type of a transformer is connected to the above arrangement? So like I told you all, it is a step-down transformer. Step-down transformer. Step-down transformer. Is that clear? Step-down transformer. Then the next question, same introduction and the diagram is given to you. In what coil in this transformer should wires of higher diameter be used? State the reason for it. So I explained this to you all, students. We are using a step-down transformer. Step-down transformer. Now when you say a step-down transformer, you know the symbol. We have more turns in the primary coil than the soft iron core, whereas you have a few turns in the secondary coil. So here we take the V primary, V secondary. So obviously V primary is greater, 240 volts, and here we get 12 volts. But if you consider the I primary and I secondary, obviously I secondary will be greater because you know the equation, power is equal to V into I. So when voltage decreases, I increases. Now you all know, students. Now when there needs to be more current flowing, the resistance has to be less. If you need current more, has to be more, then resistance has to be less. Now, what are the factors that affect resistance? The material, the conducting material or the material composition of the conductor that we can't change in the household circuit. You need to have the length of the conductor, but here the length depends on the number of turns, which in turn determines the potential difference. So that also you can't change. The third factor, cross-sectional area of the conductor. So cross-sectional area. Sectional area of the conductor. So if that increases, when the cross-sectional area increases, you can remember the resistance decreases. So if we want a higher current to flow, we need to reduce the resistance. For that, we need to increase the cross-sectional area. So we need to use a thick wire. So where do we use the thick wire? In the secondary coil. Not the primary coil, we need to use it in the secondary coil. So the question here, in what coil in this transformer should wires of higher diameter be used? State the reason for it. So here we have to say secondary coil, then we have to say because the efficiency of the transformer is 100% when V secondary decreases, I secondary increases. For a higher current to flow through a conductor with higher diameter has to be used. So that the resistance will be reduced. Now, why do we need to reduce the resistance? That also you all know. Now, normally when there is high resistance, there is certain amount of current or voltage used up against the resistance. And that current is converted to heat energy. So, here also, if you don't reduce the resistance, there will be more heat produced. So, that also can be given here. Or you can say, or we can say, or to reduce the heat generated due to resistance. Now here also students, I have given a complete answer where I have explained about the efficiency and the increasing in current. But if you want to make it a bit shorter, you can also start from here. When for a higher current to flow through a conductor, we need to have a conductor with a higher diameter so that the resistance can be reduced. So that will lead to the reducing in heat generated due to resistance. So that is what you need to write here. Is that okay, student? So that is the secondary coil has to have a conducting wire with higher diameter, and also the reason is to reduce the resistance. Is that okay, student? So with that, I'll move on to the next question. Here again, the diagram is given on this side. Now we have the question here. The number of turns in the primary coil of the above transformer is 1800. What should be the number of turns in the secondary coil? Now for this, you all are familiar with the equation. We normally write it as number of turns in the primary coil divided by number of turns in the secondary coil is equal to voltage primary divided by voltage secondary. Now from this, here we need to find the number of turns in the secondary coil. So there we can rearrange the equation and we can write it as number of turns in the secondary coil is equal to number of turns in the primary. So you can have number of turns in the primary coil multiplied by voltage of the secondary coil divided by voltage of the primary coil. You can write this equation, rearrange, or you can write this equation, that is fine, and then you have to substitute. So here we have the number of turns in the primary coil, so that is 1800. We need to find the number of turns in the secondary coil. We have the potential difference. Primary is 240 volts and secondary 12 volts. So from that, if you calculate the value, here you will get it as N secondary is equal to 1800 into 12 by 240. So here we can simplify, we can cancel off the zeros, 12 and 24 2. So when you simplify, you get it as 90. So there are 90 turns in the secondary coil. 90 turns. So there also you can see it is a step down transformer. You can even calculate the ratio 204 to 12, 20 is to 1. So 1800 is to 90. So that is also 20 is to 1. 90 turns are there in the secondary coil. Is that okay, student? So with that, I'll move on to the next question. Third one, illustrate graphically how the 12 volt alternating voltage supplied by the transformer varies with time. So it has to be an alternating current. So there you need to show it using a graph. Now here we can have a graph like that. Here you will have the voltage. So voltage and time. So then we can draw the graph like that. So it has to be an alternating current. Now this alternating current, here I have started with this point and the waveform goes that way, or else we can also have another two types of graphs. I'll draw both the graphs. Here also voltage, here it's time, voltage, where you can start the graph like that and it can go on, or you can even start the graph from here like that. So that way also you can draw the graph. So as long as you show that it is alternating current and try to draw it a more symmetrical graph. So one of the three graphs can be shown. So as long as you show it as an alternating current, that is fine. Voltage and time. Is that okay, student? You need to know, just draw only one graph. So with that, I'll move on to the next one. Fourth one, draw using standard symbols how the four diodes are connected in the full wave rectifier circuit. So you are familiar with the full wave rectifier circuit. So here of course we have the current flows through this, but you all know the current has to flow in this direction. Here it flows this way. Then you need to have a diode like that. This means and from here of course the connection goes like that, because you get the connection here. So the important part is this, where you show the diodes like this. these two will be forward biased, when these two are reverse biased, or when these two are forward biased, these two will be reverse biased. So that is the way you need to show the diodes. You can draw this diagram or you can show it in another form where we have the diodes drawn like that, but the connection will be this way. And here also there is a connection. The same thing, the same diagram, it can be drawn this way also. Here you can see this and this at an angle. Here also they are facing towards each other. So when these two are forward biased, these two will be reverse biased, or when these two are forward biased, these two will be reverse biased. Like this also you can draw the diagram. So one of the two diagrams can be used by you all. You can draw one of the two diagrams to show the 4 diodes of the rectifier circuit. Is that clear, students? So with that, I'll move on to the next question. So this is actually the last question of the paper. Again, we have the diagram and the 5th part, name the device indicated by X. So here you can see the device X. That what is that? Now here you have the direct current voltage that is being smoothed. So smoothing process, I told you all, it is the capacitor. So here the answer is capacitor. Capacitor. Is that clear, students? So with that, I have completed all the 9 questions of paper 2 as well. So we started off by discussing the MCQ questions. You all are familiar with the instructions. You have to answer all 40 questions. That counts for 40 marks. Then in paper 2, part A is the structured type questions where the first 4 questions are compulsory and you have to answer the questions in the space provided, and each question carries a total of 15 marks. So therefore the total marks for part A is 60. Then part B, there are 5 questions. Out of that you need to select 3 questions only, and each question is out of 20 marks. So here you can see 20 marks. So there again it is out of 60 marks. So then what happens? Part A 60 marks, part B 60 marks. In total it is out of 120. Then we divide it by 2 and you get it out of 60, and that mark is added with the paper 1 mark, that is out of 40. So then you will get your marks out of 100, which will be graded. That is how the paper is marked. So you have to remember, students, you have to write in very neat handwriting, and all the questions, all the parts in part A of the paper have to be answered on the paper itself. And when you select 3 questions, you need to prioritize them and do the questions in correct order. Let's say you have selected the 9th question, you have to answer all the parts. Then only you will get the full 20 marks if all answers are correct. If you leave out any parts, then you will be losing marks. And you have to answer them in the booklets provided, and you have to write all the answers for all the parts together. You shouldn't write them in different pages. In the sense, you shouldn't write answers of different questions in adjacent pages. If you start question number 9, complete all the answers. If you don't know an answer, leave some space. Then you go to the next question. So before doing that, you have to read the instructions given in your booklet as well. So then you will answer them correctly. So I am sure with all these instructions and the discussion, you will be able to answer the G.C.E. O-level paper.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.